firstly, we obviously need to know what a base is. Now, a base is essentially a compound that can neutralise an acid. Now, what that means is the solution that's formed has a pH of 7. Now, we will get into this in the next part, but essentially an acid is something that has a pH of less than 7 and a base has a pH of more than 7. When the two react together, they neutralise, and the resulting solution has a pH of 7. Now, they are a group of compounds, and so there are different types of bases that you need to know, just 2 types. So the first type does dissolve in water, and we call those kinds of bases alkalis. Now, because they dissolve in water, when you carry out experiments with them or reactions with them, they are used as solutions. One common type of alkali that you're very familiar with is metal hydroxides, particularly familiar with group 1 metals, metal hydroxides, which is essentially a metal dissolved in water. The other type of base doesn't dissolve in water, and we call them simply insoluble bases. And so when they are used in experiments, they are in a solid powdered form. Now, they're things like metal oxides or metal carbonates. Now, they don't dissolve in water, but they do dissolve in acid, and you need to know what the products are when they do dissolve in acid. Now, we're just going to go through this table again. You have seen it before. These are the charges of some common ions that you need to know. I'm hoping by this stage you've actually got quite familiar with most of them. Now, these are really going to help us when we're writing out the formula of our bases and of the salts formed. So just keep this at the back of your mind as we go through this lesson. Now, let's just delve into what the salt is. We understand that when we name the salt, we take the name of the metal, and we know that the other part of the name comes from the acid. That would be the negative ion from the acid. Now, they are ionic compounds. They have no overall charge. So when you do write out the formula of these ions, you just got to make sure that the charges of each ion add up to 0. So the sum of the charges on their ions should equal 0. Right, now let's look at our first reaction. An acid plus an alkali makes salt and water. So if you remember, an alkali is a soluble base. This is a neutralization reaction. Just some key points here. All acids contain hydrogen ions. We looked at that in previous lessons. Now, all metal hydroxides contain hydroxide ions, so that they have a -1 charge, OH- ions. Now, we can see here that water is formed, and actually you need to know this ionic equation showing neutralization and how water is formed in this reaction. So we've got hydrogen ions combining with the hydroxide ion, and we can form a molecule of water. So let's make sure we get that noted down and memorized. Now, what I'd like you to do is just have some practice writing out the formula of these alkalis using the known charges. So we know that these are all metal hydroxides. They all contain hydroxide ions. So using your periodic table, find the charge of the metal, and remember the charges should add up to 0. So let's start by writing out the formula of these alkalis. So just pause the video now and have a go. Right, let's check your answers. So well done if you got those correct. Just remember the sum of the charge of each ion needs to add up to 0. Okay, what I'd like you to do now is I'd like you to use a general formula of the reaction of acids and alkalis to firstly complete the word equation below, so hydrochloric acid plus sodium hydroxide, what is the product formed? And then I'd actually like you to write the balance symbol equation with the state symbols for this reaction. So use the general formula, complete the word equation, write the balance symbol equation with state symbols. Pause the video and have a go. Right, so what you should have got is that we know the salt formed is sodium chloride because we've got hydrochloric acid. So the chloride reacts with the metal in the alkali, so it'll be sodium chloride plus water. And our formula here below, we can see that the acid and the alkali are aqueous solutions. We form an aqueous solution of sodium chloride, but our water is in the liquid state. And we always write water with a state symbol of L. Right, let's go through the next example. So we've looked at how acids react with soluble bases or alkalis, but now I'm going to look at the insoluble bases. So we'll start by going through metal carbonates. When they are dissolved in acid, we form salt, water and carbon dioxide gas, and that's really important. And actually carbon dioxide is very visible in these reactions as bubbles. You can see the bubbles coming out during the reaction. Something to note here that all metal carbonates contain carbonate ions, that they have an overall charge of -2. So to use that to write the formula of the following metal carbonate, so just pause the video and have a go at writing out the formula. Right, let's check your work here. So calcium, for example, is in group 2. Calcium ions have an overall charge of +2, so the ratio of ions would be 1:1. So for every carbonate ion, 1 calcium ion is needed, and so on. Right, let's do a worked example. Same thing again, you're going to use the general formula to complete the word equation and then write the balance symbol equation for this reaction. Hydrochloric acid plus calcium carbonate. Pause the video and have a go. Right, this is what you should have got. So we've actually got 3 products now. We've got calcium chloride, so we're naming the salts in exactly the same way that we've been doing, but our products have slightly changed. We still make water, but we also make carbon dioxide gas. So just check your state symbols. I'm going to just draw your attention to the calcium carbonate. Remember we said that they're insoluble in water, so we often use them as solid metal powders or metal carbonate powders. So calcium carbonate should have had a state symbol S, and just note that carbon dioxide is a gas, so we should use G as the state symbol, and also just check that your equation is balanced. Okay, next example. Right, the final type of reaction that you need to know about is how acids react with metal oxides. Remember, these are also examples of insoluble bases, but our products are a bit more simpler. We just make a salt and water, no gas is made. So we need to remember that all metal oxides contain oxide ions, and oxide ions have a -2 charge. So like before, could you please practice writing out the formula of the following metal oxides? So just pause the video and have a go. Check your answers there. Remember, the charges of each ion or the ions in the formula should add up to 0. And could you have a go at completing this worked example? So use the general formula above, complete the word equation, then write the balanced symbol equation with the state symbols have a go now, so just pause the video. Right, so we make copper sulfate because we've got sulfuric acid and copper is the metal, and we form water. Just going to draw your attention once again. Copper oxide, remember, they are insoluble bases, so when they react as or they're used as powders, solid powders. So you should have got an S there for copper oxide. Now this is actually a very common equation that crops up a lot for this topic. It's actually associated with a required practical that you need to know. You need to know the method and so on. So we need to know exactly how we could make salts like copper sulfate in a lab. Now the idea is we're going to have an acid and we're going to have a base, but you need to know the techniques used to actually just separate the salt from the products, and we're going to go through that now. Now the first stage is obviously we need our acid, so we're going to suggest a sensible amount of acid, measure that in a measuring cylinder, let's say 50 centimetres cubed of sulfuric acid into a beaker. Then you would use a spatula to measure out your copper oxide. A good suggestion is to start with 3 to 4 spatulas of the copper oxide. Remember, it is a powder. And then you need to start dissolving that. Really going to help is if the acid is gently heated, that's going to ensure that powder dissolves in that. And you're going to keep stirring and keep adding more metal. So you're going to keep adding more copper oxide until no more will dissolve. And that's just going to make sure that all of the acid's been neutralized and that you're going to get a really high yield or really high amount or the maximum yield of salt crystals at the end. And the way of knowing that no more will dissolve is you'll just see bits of the powder sailing on the bottom of the beaker, and no matter how much you stir or heat it up, it just stops dissolving. That's what we call a saturated solution. Now, once you've formed your solution, and there's obviously going to be some bits of undissolved copper oxide, we need to filter that out. So what you do is you get a filter paper and you line a funnel with that, and you would pour your solution through the funnel into a conical flask. Once it's cooled down, obviously it's quite warm at this stage, you've been heating up the acid, then that solution that's been filtered, we call it after the filtrate, you'd pour that into an evaporating dish or an evaporating basin. So remember, at this stage the salt is actually dissolved in that water, and to form solid salt crystals we need to evaporate that water, and there's 2 ways of doing this. You could just leave it overnight and the water would just simply evaporate off, you know, and the more shallow your evaporating dish is, the quicker that happens. Or you could speed it up even more by gently heating that evaporating dish over a Bunsen burner, obviously with a gauze and tripod, and you want to gently evaporate the water. So you're gonna place it over a beaker half filled with water, and that essentially is going to crystallize, and you'd get left behind with these bright blue crystals of copper sulfate. Now remember guys, you do need to be able to recall that method and also justify each of the stages used in that experiment. Just the last question to think about: if we used hydrochloric acid or nitric acid instead of sulfuric acid in this reaction, would the salt be different? Would the products be different? Something to think about. Just pause the video and have a think. Right, yes, of course. If you change the acid, the salt formed would be different. Because remember, half of the salt comes from the type of acid. So although you could still use copper oxide, if we use hydrochloric acid, we'd make copper chloride, and if you use nitric acid, you'd make copper nitrate. So yeah, the acid, the type of acid used will determine what salt is made.